Hello everyone, I'm Vipul Chakravarthy. Welcome to day 3 of Intro to Data Structures and Algorithms. Yesterday we have discussed about arrays and linked lists. Today we are going to talk about stacks and queues. First of all, I'm going to give you a brief introduction about Newton School. Newton School is one of the best initiative taken up from IIT graduates uh, to help the people, those who are really uh, struggling to understand the computer science fundamentals and to get a good an overview of all the subjects that they need to cover as for a software engineer. So if you open up the Newton School website, you can just sign up here directly, and after registering from this on this website, you will be able to see the you will be able to open up your own once you have just logged in, you can just see the tracks here. Tracks in the sense we have multiple tracks that we are running currently, and in addition to that, there is a new uh, initiative taken up by Newton School itself, that is Launchpad, where a beginner, a complete beginner for computer science can just come and enroll for any of these courses and just start following up these courses. This will be something like a beginner level courses, which will give you a good fundamental for all the uh, prime courses that we need in a computer science. So I have for suppose if you want to enroll in any of this course, for suppose this is intro to JavaScript course, you can just click on that course. You can apply here. Simply, if you submit and if you start the course, then your course will be available here in that name. So I have already registered in the course Introduction to Data Structures and Algorithms. So if you open up the course, you'll be able to see all the lectures that were already done for that particular course. And if you want to add a doubt, or if you want to ask a question to the instructor, you can just put your doubt here. That questions will be solved definitely within a minimum time, and you can check all the doubts that were asked about this particular course. All right. So this is about the tracks, and we also provided an playground. It means an IDE where you can just create your own IDE here with some kind of you can just create your own IDE here, and you can write up the code in any of the language that you want. And it is something like you can give up the input, you can take up, you'll get the output here. So that would be really useful for you rather than using your own code editor in local or any other editor in the different websites. All right, cool. So this is all about the Newton School and Launchpad. So next, coming to our uh, lecture. So those who have missed the video of linked list and the rest, please check it on our website. Please enroll to that course so that you will be able to follow that particular uh, topics that we have covered yesterday. Because without understanding linked list, you can't understand stacks and queues. So that will be a prerequisite for you. Please go and watch that video first, and then you can uh, start watching this video. All right. So yesterday we have discussed a couple of things about linked list, how we use linked list, why we are going to use linked list, and we have implemented the linked list as well. And we have tried to add some elements onto linked list, and we are able to make it work. All right. So one of the what are the basic applications of linked list? So if you check up, if you see something like, for suppose if you're using a code editor, and if you want to store up the elements, so we always use Control C, Control V, and most probably you'll also use Control Z, right? Control Z in the sense it is nothing but undo operation. So half the system is going to get track of all the undo operations that you're doing. How can it will be storing all those things? It is simply using a stack there. Stack is nothing but last in first out. Okay. So a much more real-time example could be something like if you're uh, putting up the pile of books there, books in the sense you'll just put one book, and on top of it we'll put another book, and on top of it you'll put another book. Assume that these all are put in such a way that you can just remove the book only from top of it. It's not like you're taking it from a middle. So that is a real time example for a stack. And you also take pile of plates that you keep it in your kitchen, where you put one over the other rather than putting up in the middle or at the last, right? So that is a basic example of stack. And so how are you going to implement the stack? You can implement stack using linked list. You can implement the same stack using arrays as well, but we follow linked list because linked list will make our thing easier when you are inserting and deleting rather than the arrays. So definitely we'll follow the same way. And here, now as we are calling it as inserting and deleting, we have specific names when coming to stack. It is something like when you are inserting, it is called as push, and when you are deleting, it is called as pop. Okay. So the main funda here for stack is in a linked list, element will be added from the same end and deleted from the same end. That is called as a stack. Okay. So to get a clear idea, if suppose, uh, just a second. Okay, this is one node, this is the other node, this is the other node. All right, so assume that this is one linked list having 1, 2, and 3 as the values. And inside this, we are going to, so for suppose if you're inserting from the same end and deleting from the same end, then it is called as a stack. Okay, all right. So inserting and deleting from the same ends. It can be on the front end, it can be on the back. It doesn't matter. But my preference is always inserting on the front and deleting from the front. So I'm following this. You can also do from the end, it's from the back itself. It doesn't matter. But the thing is, you need to insert from the same end and then you need to delete from the same end. That is uh, the key difference of a stack and queue. Okay. When coming to queue, it is something like the same thing, but you will insert from one end and delete from the opposite end. That is the main difference between stack and queue. Okay. So yeah, this is a theoretical definitions that we have whenever you're going through stack and queue. But if you want, we want much more clarity about that, right? So all right. So if you remember that yesterday we have created a linked list class, and inside using that linked list class, we also created a node. All right. So as we have a linked list class already, in a similar way, we can also create a class for stack. Okay. We are going to create a stack for class. All right. So cool. So for the same stack class, what kind of class variables do you want, and what kind of methods do you want? So stack, as we have discussed already, stack will do two operations: inserting and deleting the elements. So that insertion operation is called as push. You need to push an element. For simplicity, I'm keeping all the elements as integers, and I need other thing, and here I need to return int, and I am popping out the element, delete. So whenever you're pushing the element, it will be added, so it won't return anything. Whenever popping the element, it will return the it will delete the element that is in the front, and it will return that value as well. So these are the two methods. All right. So what are the class variables that you want to uh, uh, maintain? Simply like how we have our our linked list, we are also maintaining the same head we have, so that it would be easy for us to maintain track of our linked list. All right. The same linked list, we are just maintaining, we are whatever the implementation that we have did, we are using the same concept but in a different ways. We can see, when you have a linked list, yesterday we have discussed it, inserting the element at the back, right? In a similar way, now we are making it to insert from the front, and we are making it to delete from front itself. We can use all the possibilities that we have, right? It depends on how we are implementing the data structure. So if you implement in this way, in this fashion, it is called as a stack. Okay. Once we're done with stack, then we will go for the queue implementation. All right. So now what we discussed. So in a linked list, if you're going to add from front, okay, if you're going to add from front, we will call that particular thing as uh, push or inserting at the front. So for clarity, I'm writing up comments also here. Insert at the beginning. Delete from the beginning. All right. So when you're inserting, what you need to do? We need to create a new node. First of all, new node of element. It will create a node now. All right. And what is the corner case that we need to check? Whether there is a head present already or not. If there is no head present, then we are going to make this dot head, this dot head equal to new node. Done. So this case will work only when there is an empty stack, or when there is no element present. Then definitely, if there is no element present, definitely the head will be null, and we are checking that condition. For suppose if the head is present already, there is an element, but now you need to insert an element at the starting. How we are going to do? We'll see. What we can do? Node is already created. What we can do? Simply, can we just make the new node dot next equal to head? It means the newly created node will be pointing to the head that we have currently. And what we need to do, as this particular new node is inserted in the starting, we need to make it as a head, right? Simple. So we are going to make head equal to new node. This is the main idea of like inserting the element at starting. Don't get confused. I'm once again repeating the same thing that we have done now. Inserting an element at the starting. Good. So if you don't have any elements in the linked list, then that's fine. It is simple. Saki, just you don't have any element. You're just making the created node will be the head. All right. If you already have an element inside the linked list, and now you need to add an element now. You need to add an element at the starting. What you will do? You have created a node already, but this node doesn't have any link with our linked list. How we can make a linked list to be connected with this particular node? They're just making this particular node dot next equal to the head that we have, and we are changing the head to the first node. We are changing the head to the newly created node. Simple. Now your head will be there in the new node, and you have the all the elements that are already added into the linker list. Understand? Cool. So this is about inserting the element at the beginning. Good. Next, so what if you want to delete the element from the beginning? It is even it is also a so simple method. We are going to delete the element, right? So what I'm going to do, element to be deleted equal to head, and head equal to head dot next. Simple. It is something like element. I want to delete an element. I am copying the head that I have already, and I am pasting. I am modifying the head. Modifying the head that we have, head equal to head dot next. It means that the head will be changed to the next element, and simply return element to be deleted dot data. And we have a corner case here. If you don't have anything, head is null, then return -1. Simple. All right. Yeah, that's all. This is the stack. Now you are able to create your own stack using the methods that you are following. That is simply like pushing an element in the starting and deleting the element from the end. We will try to uh, yeah, we will try to test this up. Okay, so inside this linked list, rather than this linked list, I am making it a stack. Stack is the object name. Stack dot head. Stack dot push. And we'll do one thing. We will add a toString method inside this itself, like how we did for linked list yesterday. That could be really easy for us to print up all the elements that we have here. And I'll try to print this inside uh, inside a string because that will be easier for us to understand. Str plus equal to element plus system dot out dot println of str. So this need to print the yeah temp equal to head. Yeah, this will be same anywhere. You're just printing up the element so that the whole linked list will be printed. Yeah, I'm just separating that with some arrows so that it would be easier for us to understand. I've pushed an element, and first we will do one thing. We will try to just a second. Yeah, we'll try to print the stack every time. Stack equal to stack. Okay, and we will copy this. We'll paste here, copy this, paste here. Okay, the stack will be returning up. The stack dot print will be returning up the the string that we have that we are iterating through, and it will iterate through all the elements that are present in the string. And so we are just checking up. So first of all, in the initial state, what the stack will print? It will be definitely null. I'm just checking with the head. Okay. Next, pushing up some value here, pushing up another value here, and every time I'm checking whether it is working with the push thing or not. Okay. Let's see. Um, so I would like to run it now. Oh, just a second, guys. I guess whatever the stack implementation that we have written is like it is overwritten. No issues. I'll just uh, do it the within a time. So node will be at starting and initializing that with null, like void pushing an element inside that. Public and pop. when you're pushing, we already discussed that the element need to be inserted at starting of the linked list. Insert at front. Now create a new node of element. Once the element is created, we can just simply check whether the head is null or not. Head equal to null. If the head is null, then make the head equal to new node and return it. So you have successfully added an element if there is no element present. If the element is uh, if there is already an element, and if you want to add other element from the front, then you need to what you need to do. The node is already created. Just make new node dot next as the head that we have, and new node, and now the head will be a new node. Okay, that push method will not won't return anything because it's just an add method, and pop will need to return something. It is something like if so you need to change the head, right? So now element to be deleted equal to head, and head equal to head dot next. We'll definitely change the element to the next one, and you need to return the value that we have inside this data. And the corner case that we need to check is if head is equal to null, simply return -1 -1. Yeah, so I'll be writing up I'll be writing up the print method that we have already. I'll be using the same method here to print the stack as well. And here I'll maintain a string str equal to empty in the starting stage. And here I'm just appending that into this str that we have. Every time when an element is added, I'm just maintaining a link between both of the elements and return this str. All right, so where is my main method? This is the main method. This is the main class that I have. I'm just putting up below the stack class, and apart from this linked list, we are creating an object for stack and change the name as well, which we have as list onto stack stack. I'm just trying to dot out dot println of str. It will print the element. It will print the stack. So every time you can just call once you have added the elements. Here we have add element method, but we need to replace that with push that we have. And here, yeah, we have, right. So now I've created an object for stack. Initially, I'm just printing up the head, what is it, and pushing up the element, printing up the whole stack, again pushing up the element. Okay, I'm creating a stack object, pushing it and printing the whole stack, pushing other element and printing the whole stack. Let's check what how this is going to happen. Uh, so let's run the program. Yeah, so if you check it now, before adding any element, it is something like null. First element pushed is 6, 6 is pushed. Next element pushed is 8, 8 is, and again inserted at starting. Again, 9 is pushed, 9 is inserted at ending. So if you want to uh, pop the element as well, stack dot pop. So it will return an element. So deleted equal to this element, or simply I'll just write it inside dot out dot println of stack dot pop, because it will return the element that is deleted. Element deleted. Okay, so the element delete at this point, the element deleted need to be 9, and if you do it again at this element, the element deleted will be 8, right? Or you can just simply call the stack.print as well. You will be understanding like what is there inside the linked list as well. We'll run and check. Cool. So if you see, 6 is added first of all. Next, 8 is added in the starting. Next, 9 is also added. 9, 8, 6. Next element deleted will be 9, because we are deleting from the front end. So the first element will be deleted. 9 is deleted now. Cool. And the next element will the head, where the head will be at 8. Now the 8 will be deleted. The same thing that happens with then the last element which is present in the linked list in the stack is 6. So this is the simple implementation of stack. Cool. And now we can talk about queue as well. Queue. When coming to the queue, it is also similar to stack, but queue is something like in stack it is last in first out, right? But now in queue it is like first in first out, which will be inserted first, that will be deleted first. Okay. So the real-time practical example that we can see is queue. The name itself suggests that queue is nothing but uh, there are people standing in a line near a ticket counter, or people standing in near the bus that they want to board. Okay, so this is a real time example that we have due to queue. And here it is like in stack we have inserted from the same end, and we have also deleted from the same end. But in queue it is a quite opposite. It is something like we will insert from one end and we will delete from the other end. Okay, for making it simple, we are inserting from the back end. It means we are inserting from the last, or we are inserting from the rear end, and we are deleting it from the front end. Okay, all right. Next with so in stack we call these operations as push and pop, but in queue we call these operations as nq and dq. Okay, and stack didn't have any kind of variation. Stack is a single like a single fashion that we follow stack in a single fashion. But queue we have different variants. One variant we call it as a circular queue, where the head also will be connected to the last pointer, like it will be a circle. And the other queue that we have is a priority queue. We're no need to worry about priority queue. We will be anyways discussing that priority queue in the further lectures. Next thing is a double-ended queue. Double-ended queue is nothing but until this point we are just making uh, inserting from one. We are making the inserting and deleting from one end. We call it as a stack, and inserting from one end and deleting from the other end. We call it as a queue, right? But double-ended queue is nothing but double-ended queue, or DQ or deck, is nothing but we can make all these four operations to work. Four operations inserting from the stack, delete from the stack, inserting from and deleting from end. To make possible these four operations, we call that particular data structure as double-ended queue. Simple. All right. Now we will see the same like how we saw the implementation of stack, we can also see the implementation of queue as well. All right, class queue. So now the question is, will it make the same if you use the single pointer like how we used for stack or linked list? Because we are saying that we need to delete from the last end. We are saying that we need to insert from one end and delete from the other end. Will that make the same sense, or is it? Will it? Can we make it much better using any kind of hack that we have? Just think a while before moving on to the solution that I am saying. All right. So the easy way to reduce the complexity of insertion and deletion, we'll just maintain two pointers here. One is something like head, the other one is something like tail. What these two will do, because the head will be at the front end and tail will be at the back end and the rear end. Okay. That will make our things easier. Let's see how it will make our things easier. Void, and what we said, when you are adding an element, we call it as enqueue, and to add an element we need that element as well, right? This is a function signature. As we are adding, we don't return anything. That is why the return type is void. And the other one is dequeue, where we need dequeue will return an element which is deleted from the front end. So this is a function uh, signature that we have. All right. Now, enqueuing the element, it means you need to add the element at the last and delete the element from the same from the front. Okay. So adding an element at the last. So will you traverse the whole uh, queue from the starting, or will you just change the tail that we are also maintaining? Which will take lesser time, traversing the whole queue or just changing up the tail that we have already? Simple tail, right? So that is the main reason that we are maintaining the second pointer, which is a tail. Okay. So first of all, simple, we'll just check whether there is a tail or not. If there is no tail present, it means that there is no element is added until this point. And if tail is not present in the sense, it means that even the head is also not there. So we will make head. Yeah. Before that, we need to create a new node, right? Node equal to new node of element head equal to new node, comma, tail equal to new node. Simple, and return. So what are we doing here? If the tail is null, it means that the tail, we didn't even add any element until this point, and so there is no element inside the linked list. What we are in the queue, what we're doing now, we are just maintaining. We have just created a node and making that as head and tail, because if there is no elements, if there is only a single element inside the queue, that element will be pointed with head and tail, right? Because there are no other elements present. Okay. For suppose if you have already, there are some elements present in that queue. So tail is at one particular node. So what we are going to do now? Simple. The current tail that we have dot next will be referring to new node, and now the new tail will be new node. The same thing that we have did when we are adding the element at head, but the only difference is we are just making it as, we're just maintaining a separate pointer, and we have named that particular pointer as tail. Simple. So this is about enqueue operation. Now the dequeue. Dequeue, it is something like we are deleting from the front end. How we are going to delete from the front end? We'll check whether the head is there or not. And if there is no head present, we are returning with -1. And if the head is already present, node element to be deleted equal to head equal to head dot next, and return element to be deleted dot data. All right. Simple. The dequeue operation is same like how we did in the stack, because the same we are just deleting from the front part. So the operation will be same here. There is no difference between the DQ and pop operation that we are doing for stack. The only thing, the insertion differs when you're dealing with the when you're checking that with the code wise. So did you understand why we have maintained a another pointer? Without another pointer, if you want to enqueue if you want to insert an element in a queue, it will also, it will take, you need to traverse the whole queue, right? So it will create it will create much complexity than because it will create the same complexity because traversing the whole queue, if you have any element, it is so often. So we are not going to deal with that complexity, because the main aim of our algorithms is always to reduce the time complexity. So that is the reason I've just maintained the single point, other pointer, and it is called as a tail, and it's always pointing to the end or the rear part of the queue. All right. Okay. So we also have the print method that we have used, and we can use the same method here inside this as well. Print. No, yeah, this method will be same anyway. We are not going to change this method because this method will be always um, printing up the whole queue. All right. So instead of stack, we will just replace that stack with queue, and the object will be queue. This is queue, and the push operation that we did, the push operation that we did need to be replaced by NQ, and the pop operation need to be replaced by DQ. The print method will be same anywhere in the queue. So let's see like how our program is performing. Yeah, same thing. So if you want to change the elements, so suppose 10 is added, and next 9 is added, and next 7 is added. We'll run it again. All right. So if you see, the 10 is added starting, and next we are adding 9. If you observe the difference, earlier it is used to add in the front part. Now if you see, the elements are being added in the back part. It means on the rear end. Okay. Again, I have added other element which is 9, and next I have added another element which is 7. 7 is also added. The element now. So if you want to delete what we have seen, so this is the elements that we have in the queue: 10, 9, 7. What we have discussed, what is the operation to delete in queue? It is dequeue, where it will delete the element from the front end, which is first inserted into the queue. That will be deleted first. Simply 10 need to be deleted. So this is what the 10 is deleted. Next element to be deleted will be 9, and the element deleted, and at last the queue has only a single element, which is 7. This is about the queue implementation. Simple, right? It won't take much time. And see, always data structures and algorithms, you won't get it when you're simply watching up the video or simply just reading up the code from any of the site. It is all about, you need to write your code on your own. You need to have that hands-on experience when you're writing up. That will be really helpful for you to understand, okay, this is how we are learning data structure, this is how the queue is there, this is how the stack is implemented. And if you write your own data structure, then only it will be then only you can understand where to use this particular thing when you're coming across some of the competitive programming questions. All right. Simple. So next we already discussed about queue, right? Next we can talk about the other implementation of linked list. It is simple solution. It is a simple thing called as doubly linked list, because yesterday we have discussed the linked list where we have only a single link, which will point always to the next node, right? Next node in the sense the element will be connected to the other element using a link, which will just tell you the next element. It won't give you anything apart from that. Now, in a doubly linked list, we will maintain two links. Okay, two links in the sense, you need to you will have the next element. At the same time, you will also have the previous element. All right. I'm again repeating the thing. Doubly linked list will have two links for every node, something like the next link, then also the previous link. Simple. So what is the advantage of having the double linked list? So earlier when we talk about single linked list where we can traverse only from in a single direction from the head to the last. Okay. But using a double linked list, we can traverse in two ways. We can also traverse from last to first, and you can traverse from first to last. So what will it take in extra? Definitely it will take some memory, right? Because we are maintaining two pointers for each and every node that we are creating. So each and every node, in the sense, for every node that we have. So right now, until this point, the node class that we are just having only one pointer and one element which will store, one variable which will store the data of that particular node. But now you need to maintain another pointer which will point to the previous element all the time. Okay, so this is about the doubly linked list, and this so if you want, you can just write your own implementation of double linked list. I'm not going to implement it. You can simply uh, write it using the same, like how we have a single linked list. You can also maintain the double linked list. Just you need to check is inside the node class, you need to update just with some previous element. So whenever the element is created, you need to make it as null in the starting, and using that logic, you need to make some minor changes inside the linked list implementation that we have did already. Just do it. You will you'll be able to do that. It's not a big deal. Okay. So, all right. So we discussed some points saying that insertion and deletion are really easy in a linked list. Did you meet that? Did you agree for that point now after seeing the stack and queue implementation? You need to agree, because if you see the insertion of an item and deletion of an item inside a stack, how much time complexity it is taking. Is that using any loop here? You can see the code directly there. Just see and let me know whether can you like is that really traversing throughout the array, throughout the linked list, or is that simply doing it an operation at a constant time? Just see the code, and you need to analyze that whether it is taking up a time or not, how much time it is taking to do that operation. So if you see the code, there is no loop that we are using. We're just simply changing up the links that we have for the head, and we are just maintaining the we're just copying it, changing the reference of the head. That's the only thing that we are doing in insertion operation in a stack. So it will take a constant time that is simply O of 1. Okay. When coming to the pop operation in the stack, same. Here also we are not traversing throughout the linked list or the stack. We are just changing the head, copying the head element into the head node, and we are changing the head to next element that we have. What will how much time it will take? It is also a constant operation. There is nothing like a loop here. We are not traversing, so it will take just O of 1. Cool. Next, coming to the queue as well. Even inside the queue, the insertion takes O of 1, because there is nothing like a loop there. It is simply copying up and changing the tail. Simple. Next thing, again with the DQ. Even DQ does the same thing. It will just change the head, that as we have discussed in the stack, the same thing will be done in the queue deletion operation, that DQ operation. Even this is also will be happening inside the time of O of 1. So that is the main difference between arrays and linked list, where arrays, when you want to insert an element or delete an element, you need to copy the whole array and you need to increase the size of the new array. Then you need to assign the new element. So that is literally costlier in arrays, but in linked list, it's very easy, where you're just maintaining everything that you want inside O of 1. That is a prime difference, and the biggest advantage of using linked list. All right. So this is all about today's lecture. It is more like changing, like linked list. These are the applications of linked list or stack and queue. Inside stack, how we are going to implement stack that we have discussed, and also queue, how we are going to use queue is also discussed. And we have seen the implementation on overall, and this is how the insertion and deletion happens. That is the main what is the difference between the array implementation, array insertion and deletion, and stack or the queue insertion and deletion. And stack and queue will be layer which will be very much useful when you're using graphs. That is also graph is also one of the data structure we won't discuss in this lectures, but yeah, I'm just giving you a brief idea about the graph. Graph is something like the nodes connected in a different fashion, like how not like in a sequential manner. Graph will be done it in a non-linear manner. So there for the traversals, we always use stack or queue. All right. So this is all about stacks and queues. We will discuss tomorrow about some of the sorting algorithms, which are really important when you are developing any kind of application, because the most of the applications need that sorting feature, and that is really important topic inside algorithms. So tomorrow we'll be discussing all these things. Thank you all.